Close your eyes for a moment and imagine you are in a spacecraft. The engines are ignited, energy flows without limits, and you begin to accelerate faster and faster. The stars turn into lines of light all around you. You accelerate more and more, but then something strange happens. No matter how much energy you add, no matter how powerful your engines are, there is a speed you simply cannot reach, an invisible wall in the universe that no technology, no amount of energy, no civilization, however advanced, can ever pass through. This is not a technological limit, nor is it a barrier that we will one day overcome with more sophisticated engineering. It is something much deeper, much more fundamental. It is a law written into the very fabric of reality, and that law states that nothing, absolutely nothing with mass, can travel at 300,000 kilometers per second. But here is what is truly fascinating. What will keep you awake tonight as you explore this mystery with us on Nocturnal Science, your nightly refuge for the deepest enigmas of the cosmos? This limit is not really about light. Light was simply the first thing to reveal this secret to us. This limit is about something much more fundamental. It is about time. It is about causality. It is about the very structure of how a coherent universe can exist. Think of it this way. We live in a universe where causes precede effects, where the past is fixed and the future is open, where you can remember yesterday but not tomorrow. This temporal structure that we take for granted, this arrow of time that defines our existence, is completely dependent on the existence of a cosmic speed limit. Without it, everything falls apart. Imagine for a moment that you could travel faster than light, not just a little faster, but significantly faster. What would happen? The answer is not that you would reach your destination sooner. The answer is that you would arrive before you departed. You could receive a message before it was sent. You could see effects that precede their causes. The very concept of before and after would lose all meaning. Reality, as we know it, simply could not exist. And yet, here we are existing, thinking, wondering about these things, which means the limit must be there. It must be real. It must be absolute. Tonight, on this contemplative journey we undertake together, we are going to explore why. We are going to discover how humanity came to know this precise number, 299,792 kilometers and 458 meters per second. We are going to understand why the energy required to reach this speed becomes infinite. We are going to experience what happens to time and space when you approach this limit. And we are going to contemplate the most beautiful paradox of all, that this limit is not a prison, but the very condition that allows you to exist to wonder about it. Because, you see, we live in a universe of limits, but these limits are not cruel restrictions imposed by an indifferent cosmos. They are the rules of the game. They are the parameters that make it possible for there to be a game in the first place. Without gravity, there would be no planets. Without electromagnetism, there would be no atoms. And without a cosmic speed limit, there would be no causality. There would be no history, no memory. There would be no you. The speed of light limit is not just a curiosity of physics. It is the signature of the universe. It is the way the cosmos says, these are the rules. Within them, anything is possible, but without them, nothing makes sense. And the most unsettling thing of all, what makes this limit so profoundly mysterious, is that we do not know why the number is exactly that. Why 300,000 kilometers per second, and not double or half? The universe could have chosen any speed as its fundamental limit, but it chose this one. And with that choice, it defined everything else. The size of the observable universe, the destiny of the stars, the possibility of life. Everything flows from this single number. So, settle in, breathe deep, let your mind expand toward the biggest questions we can ask. Because tonight, we are not just going to talk about speed, we are going to talk about the nature of reality itself. We are going to explore why the universe is the way it is, and not otherwise. And perhaps, just perhaps, at the end of this journey, we will understand something profound about our place in this limited but infinitely beautiful cosmos. The limit exists. It is real. It is absolute. But it is not the end of the story. It is the beginning of the deepest understanding humanity has ever achieved about the nature of space, time, and existence itself. Welcome to the speed of light. Welcome to the limit of the universe. Welcome to nocturnal science. In the year 1676, a Danish astronomer named Oumuamua was doing something seemingly routine, observing the moons of Jupiter. He was not looking to revolutionize our understanding of the universe. He was only trying to create accurate tables of when the moon Io would disappear behind the gas giant. But what he discovered would change everything. He noticed something strange, something impossible to ignore. Io's eclipses were not happening when they should. When Earth was closer to Jupiter, the eclipses arrived early. When we were farther away, they arrived late. The difference was approximately 22 minutes over the course of the year. Oumuamua did something brilliant, something only a truly scientific mind would do. He did not assume his calculations were wrong. He did not blame his instruments. Instead, he proposed something revolutionary. Light does not travel instantaneously. It takes time to cross space. And those 22 minutes of difference were exactly the time light needed to cross the additional diameter of the Earth's orbit. Think about it. For all of human history, light had seemed instantaneous. You light a candle, and the room illuminates without delay, without waiting. But Oumuamua was saying that light travels, that it has a speed, and using only the eclipses of a distant moon and simple geometry, he calculated that speed, around 220,000 kilometers per second. It was not perfect, but it was astonishingly close to the truth. The scientific world did not immediately believe him. It was too strange, too counterintuitive, but the seed was planted, and over the next 200 years, other scientists would refine this measurement again and again, each time getting closer to the fundamental truth. In the year 1849, a French physicist named Hippolyte Fizeau devised an ingenious experiment. He shone light through a spinning toothed wheel toward a mirror located kilometers away. The light would travel through a gap between the teeth, bounce off the mirror, and return. If the wheel spun at the correct speed, the returning light would be blocked by the next tooth. By measuring the necessary rotation speed, Fizeau calculated the speed of light, 313,000 kilometers per second. More precise still, but it was another Frenchman, Léon Foucault, who in 1850 perfected the method using rotating mirrors. His result, 298,000 kilometers per second. Humanity was getting closer and closer to the real number, the number the universe had written in its source code. Let us fast forward to the 20th century. Physicists could now measure the speed of light with extraordinary precision, using interferometers, lasers, and atomic clocks. And what they discovered was astonishing. The speed of light was not only finite and measurable, it was absolutely constant. It did not matter how you measured it. It did not matter if you were moving toward the light source or away from it. It did not matter if the light came from a distant star or from a lamp on your desk. You always got the same number, 299,790, 2 kilometers and 458 meters per second every time. This was profoundly strange. Think of it this way. If you are on a train moving at 100 kilometers per hour and you throw a ball forward at 20 kilometers per hour, someone standing at the station would see the ball move at 120 kilometers per hour. Velocities add up. That is common sense. That is basic Newtonian physics. But light does not work like that. If you are in a spacecraft moving at 90% of the speed of light and you turn on a flashlight forward, how fast does the light from that flashlight move? Intuition says it should be the speed of light plus 90% of the speed of light. But no, the light moves at exactly 299,792 kilometers and 458 meters per second. Neither faster nor slower, always the same speed. This makes no sense. It violates everything everyday experience teaches us about how motion works. And yet, every experiment, every measurement, every observation confirms this impossible truth. The speed of light is constant in all reference frames. It was Albert Einstein in 1905 who finally understood what this meant. In his paper on special relativity, Einstein took this constancy of the speed of light and turned it into a fundamental postulate. He did not try to explain it. He simply accepted it as a basic truth of the universe and explored its consequences. And those consequences were mind-blowing. If the speed of light is constant for all observers, then something else must change. And that something is time and space themselves. Time must elapse at different rates for different observers. Distances must contract. Simultaneity must be relative. The entire Newtonian framework of absolute space and absolute time must be abandoned. But here is the question that keeps physicists awake. Why exactly this number? Why 299,792 kilometers and 458 meters per second, and not, say, 500,000 or 150,000? The universe could have chosen any speed as its fundamental limit. Why did it choose this one? The honest answer is we do not know. This is one of the fundamental parameters of the universe, like the charge of the electron or the gravitational constant. They are numbers that we measure, but that we cannot derive from deeper principles. At least, not yet. What we do know is that this number defines everything else. It defines how large atoms can be. It defines how stars shine. It defines the size of the observable universe. If this number were significantly different, the universe would be unrecognizable. Stars could not form in the same way. Atoms would have different properties. Chemistry would be completely different. And life, if it could exist at all, would be something fundamentally different from what we know. In 1983, something remarkable happened. Scientists realized that we could measure the speed of light with such precision that it was more reliable than our definition of the meter. So they did something bold. They redefined the meter. Now a meter is not a platinum bar kept in a vault in Paris. A meter is exactly the distance light travels in a specific fraction of a second. In other words, we fix the speed of light by definition. We no longer measure it. We use it to define distance itself. This is not just a technical curiosity. It is a recognition of something profound. The speed of light is not just another property of the universe. It is the property. It is the constant that connects space with time. It is the conversion factor between energy and mass. It is the maximum speed of causality. It is, in a sense, the most important constant in all of physics. And it all began with a Danish astronomer observing a small moon orbiting a giant planet, noticing that the timings did not quite add up, and having the courage to propose that light, that thing that seemed instantaneous, actually traveled at a finite speed. Since then, we have measured this speed in thousands of different ways, using lasers, bouncing off the moon, using pulsars, spinning in deep space, using particle collisions in accelerators, and always, we get the same number, 299,790, 2 kilometers and 458 meters per second. This is the number that defines reality. This is the number that separates the possible from the impossible. This is the number that makes the universe comprehensible. And this is the number that, as we will see, you cannot overcome without destroying the very fabric of causality. Imagine you are pushing an empty supermarket cart. It is easy, almost effortless. Now imagine the cart is full. You need more force, more energy to move it at the same speed. This is basic physics, something we all understand intuitively. More mass requires more energy to accelerate. But here is the strange part, the truly unsettling part. When you try to accelerate something toward the speed of light, the amount of energy you need does not just increase, it becomes infinite. We are not talking about a lot of energy. We are not talking about the energy of all the nuclear power plants in the world. We are talking about infinite. Literally all the energy in the universe would not be enough. And this is not a technological limitation. It is not that our rockets are not good enough. It is a fundamental law of how reality works. Let me explain why. In classical Newtonian physics, the kinetic energy of a moving object is simple, half the mass multiplied by the velocity squared. If you double the speed, you need 4 times more energy. If you triple it, you need 9 times more. It is a simple, predictable, in a sense, linear relationship, but Newton was wrong. Or rather, Newton was incomplete. His equations work perfectly fine for everyday speeds, but they fall apart when you approach the speed of light. Einstein gave us the correct equations, and when you apply special relativity to a moving object, something strange emerges from the mathematics. As an object accelerates, it does not just gain kinetic energy. It gains something deeper. Its effective mass increases. The faster you go, the more massive you become from the perspective of someone at rest. And the more massive you are, the more energy you need to accelerate even more. It is a vicious cycle, a feedback loop that intensifies exponentially. When you are moving at 10% of the speed of light, your mass has increased by only 0.5%, almost imperceptible. At 50% of the speed of light, your mass has increased by approximately 15%. Noticeable, but manageable. At 90% of the speed of light, your mass has more than doubled. And this is where things get truly strange. At 99% of the speed of light, your effective mass is more than 7 times your rest mass. At 99.9%, it is more than 22 times. At 99.99%, we are talking about hundreds of times your original mass. Do you see the pattern? The closer you get to the speed of light, the faster your effective mass increases. And right at the limit, just as you reach exactly the speed of light, your mass becomes infinite, which means the energy required to get there also becomes infinite. But this is not just abstract mathematics. We can see this effect in the real world. In particle accelerators, like the Large Hadron Collider, physicists accelerate protons to 99.9999% of the speed of light. Those last decimals, that tiny fraction of speed missing to reach 100%, require monumental amounts of energy. The LHC consumes enough electricity to power a small city, and all that power goes into pushing protons closer and closer to the speed of light, but never reaching it. And here is the fascinating part. Scientists know exactly how much energy they need to add for each increase in speed. Einstein's equations predict with perfect precision how much energy is required, and every experiment, every collision, every measurement confirms that Einstein was right. mass really increases. Energy really becomes prohibitive. The limit really is there. Let us think about this from another perspective. Imagine you have a spacecraft with a mass of 1,000 kilograms. To accelerate this ship to 1% of the speed of light, you would need approximately 4.5 times 10 to the power of 15 joules of energy. That is equivalent to the energy released by more than 1,000 nuclear bombs the size of those dropped on Hiroshima. And that is just to reach 1%. To reach 10% of the speed of light, you would need approximately 100 times more energy. To reach 50%, you would need thousands of times more. And to reach 99%, we would be talking about energies that exceed the sun's total energy production for years, all for a ship of only 1,000 kilograms. Now imagine trying to accelerate something with the mass of a human or a real spacecraft, with crew, life support systems, fuel, and everything else. The figures become astronomical, literally more energy than exists in entire stellar systems. And this leads us to an inevitable conclusion. It is not that we have not invented the right engine yet. It is not that we need better energy sources or more advanced technology. It is that the universe itself, the fundamental laws of physics, say no. The limit is built into the fabric of reality. But there is something even deeper here, something that goes beyond simple practical impossibility. The reason energy becomes infinite is connected to something fundamental about the nature of space and time. The speed of light is not just an arbitrary speed limit that the universe decided to impose. It is the limit where space and time fundamentally trade roles. Think of it this way. When you are at rest, you are moving entirely through time and none through space. When you start to move, you exchange some of your movement through time for movement through space. The faster you move in space, the slower you move through time, and at the speed of light, all your movement is through space and none through time. Time literally stops. You cannot go faster because you have already spent all your temporal movement. This is why photons, the particles of light, do not experience time. From the perspective of a photon, if it could have a perspective, it is emitted and absorbed in the same instant. No matter how many billions of light years it travels from our point of view, time simply does not exist for something moving at the speed of light. And here is the final reason why nothing with mass can reach this speed. Photons can do it because they have no mass. Zero. Nothing. A photon exists only as pure energy moving through space. It has no rest mass. It is never at rest. It is always moving at exactly the speed of light. It cannot go slower. It cannot go faster. It is the speed of light, or it is nothing. But anything with mass, no matter how small, faces the barrier of infinite energy. An electron, the lightest massive particle we know, would still require infinite energy to reach the speed of light. A hydrogen atom, the same. A speck of dust, a bacterium, a grain of sand, a human, a planet, all impossible to accelerate to the speed of light. The universe has drawn a line. On one side are things with mass, forever condemned to move slower than light, experiencing time, having history, existing in the causal flow of the cosmos. On the other side is light itself and other massless particles, eternally moving at the maximum speed, not experiencing time, existing in an eternal now, and you cannot cross from one side to the other, not with more energy, not with better technology, not with the will of entire civilizations. The line is there. It is absolute. It is fundamental. It is the price the universe charges for having mass, for being something rather than pure energy. This is the paradox of infinite energy. It is not that you need a lot of energy. It is that you need more energy than can exist. It is the universe saying, you can get as close as you want. You can get to 99.99%. But that last decimal, that last infinitesimal fraction, is forbidden forever. And with that prohibition comes a deeper truth. We are prisoners of our mass, our atoms, our flesh, our physical existence ties us to the side of the limit forever. There is a story that physicists love to tell. It is about two twins. One stays on Earth, the other goes up in a spacecraft and travels into space at a speed close to that of light. When the traveling twin returns, he discovers something disturbing. His brother has aged decades. He has grey hair, wrinkles, perhaps grandchildren, but the twin who traveled has barely aged a few months. It is not science fiction. It is not a trick. It is a direct, inevitable, and inescapable consequence of approaching the speed of light. Time really slows down. This is called time dilation. And it is not an optical illusion or a measurement error. It is real, physically real, measurably real. If you could travel at 99% of the speed of light for what you perceive as 1 year, when you return to Earth, 7 years would have passed. At 99.9% of the speed of light, 22 years would have passed. At 99.9999%, more than 700 years would have passed, and right at the speed of light, if it were possible to reach it, time would stop completely. Zero time would elapse for you. You could travel from one end of the observable universe to the other, crossing billions of light years. And from your perspective, it would be instantaneous. 0 seconds, not a blink. The entire universe would age eons, while you would experience no time at all. But wait, it gets stranger. Time dilation is not the only thing that happens when you approach the speed of light. Space itself begins to behave bizarrely. Distances contract. This is called length contraction. The faster you travel, the shorter the distances become in the direction of your movement. Imagine you are traveling toward a star that is 10 light-years away. If you travel at 90% of the speed of light, from your perspective, that distance would contract to approximately 4.4 light-years. At 99% of the speed of light, the distance would contract to only 1.4 light-years. And at 99.99% of the speed of light, the 10 light-year distance would contract to barely 0.014 light-years, almost nothing. At the limit of the speed of light, all distances in the direction of your journey would contract to exactly 0. The entire universe in that direction would be flattened into a single point. There would be no distance between your starting point and your destination. They would be in the same place from your perspective. And there is more. Your mass, as we saw in the previous chapter, would increase toward infinity. But something strange would also happen to your physical shape. If someone could see you while you travel at these incredible speeds, they would see you flattened in the direction of your movement, as if you were compressed by invisible forces. It is not that you are actually being compressed. It is that space itself is behaving differently. From your own perspective, you would look perfectly normal, but you would see the universe around you compressed and distorted. All this sounds like madness, like something that should be impossible, but we have measured it. We have verified it again and again. In 1971, scientists placed extremely accurate atomic clocks on airplanes and flew them around the world. When those clocks returned and were compared to identical clocks that remained on the ground, the flying clocks were slightly behind, only fractions of a second, because airplanes do not travel that fast, but exactly the amount that Einstein's equations predicted. Every day, the GPS satellites orbiting Earth experience time dilation. They move fast enough and are far enough away from the Earth's gravitational field that time for them elapses slightly differently than for us on the surface. If we did not correct for these relativistic effects our GPS systems would be off by kilometers after only a few hours. The fact that your phone can tell you your location with meter precision is direct proof that Einstein's relativity is real. And there are even more dramatic proofs. Muons are subatomic particles created when cosmic rays strike the upper atmosphere. These particles are unstable. They disintegrate in approximately 2 microseconds. In that time, even traveling at almost the speed of light, they should only be able to travel about 600 meters before disintegrating. The upper atmosphere is about 15 kilometers above the surface. Mathematically, no muon should reach the ground. They should disintegrate much earlier. But we detect muons on the Earth's surface all the time. Thousands of them pass through your body every second as you read this. How is this possible? The answer is time dilation. From our perspective, the muons live longer than they should because they are traveling so fast that time slows down for them. From the muon's perspective, its life is exactly 2 microseconds, but the distance it must travel has contracted due to length contraction. 15 kilometers become much less. So from its perspective, it has enough time to reach the ground. 2 different perspectives, 2 different explanations, but both correct, both consistent, both predicted by the same equations. This is what makes relativity so beautiful and so disconcerting. Reality depends on your frame of reference. Time and space are not absolute. They are flexible, malleable, relative. Now imagine that it is you, in that spacecraft, approaching closer and closer to the speed of light. From your perspective, everything seems normal on board. Your clocks work normally. Your heart beats at its usual rate. You breathe. You think. You exist exactly as always. You feel nothing strange, but when you look forward, toward your destination, things look bizarre. The stars in front of you would appear to change color, shifting toward the blue due to the relativistic Doppler effect. The stars behind you would shift toward the red, and due to an effect called aberration of light, the stars would appear to concentrate in front of you, as if the entire starry sky were compressed into a bright point directly ahead. If you look back at Earth, you would see something even stranger. You would see Earth moving in fast motion, people walking quickly, the sun rising and setting in seconds, the seasons changing, as in a sped-up video, because from your perspective, time on Earth is elapsing faster, much faster. Every second for you could be hours, days, or years on Earth, depending on how close you are to the speed of light. And here is the mind-bending part. This is not symmetrical in the way you might think. When you finally slow down and return to Earth, the time that has passed is not ambiguous. It is not that each twin thinks the other has aged more. No, one really has aged more. The one who accelerated, traveled at high speed, and then decelerated, is the one who has aged less. The one who remained at rest is the one who has aged more. This has been confirmed experimentally. It is not a paradox. It is simply how time works when you move at relativistic speeds. This means something profound. It means that time is not a single, unstoppable arrow that advances at the same rate for everyone everywhere. Time is personal. Your time is different from my time if we are moving relative to each other. There is no universal now. When you say at this moment and point to space, what events are happening at this moment depends completely on how fast you are moving and in what direction. Two people passing each other at high speed will not agree on what events in the universe are happening simultaneously. Events that one person perceives as simultaneous, the other person might perceive as happening at different times. The very concept of simultaneity is relative, and all this flows directly from the fact that the speed of light is constant for all observers. If light always travels at the same speed no matter how you move, then time and space must be flexible to compensate. They must stretch and contract, accelerate, and slow down in ways that keep the speed of light constant, no matter what. The universe has chosen to make the speed of light absolute, and the price of that choice is that time and space can no longer be absolute. They are fluid, they are relative, they are personal, and the closer you get to the speed of light, the more extreme these effects become, until finally, at the very limit, time stops, distances disappear, and reality, as we know it, ceases to exist in the way we experience it. This is the world at the edge of the speed of light, a world where time no longer flows and space no longer extends, a world that only photons inhabit, and we, with our mass, with our need for time, can never reach. There is an equation that everyone knows, even if they have never studied physics. 5 symbols that have appeared on t-shirts, tattoos, posters, and magazine covers. Energy equals mass, multiplied by the speed of light squared. Energy equals mass, multiplied by the speed of light squared. It is probably the most famous equation in history. But what most people do not understand is that this equation is not just a formula about nuclear bombs or fusion reactors. It is a profound statement about the nature of reality itself, and it is the final, absolute, and irrevocable reason why nothing can surpass the speed of light. Let me explain what this equation really says. It says that mass and energy are the same thing, not similar, not related, the same thing. They are 2 manifestations of a single fundamental thing. Mass is frozen energy. Energy is liberated mass, and the speed of light squared is the conversion factor between them. Think of it as 2 different currencies. You can have dollars or you can have euros, but both represent value. Similarly, you can have mass or you can have energy, but both represent the same underlying thing, and the speed of light squared is the exchange rate between these 2 currencies of the universe. Now, the speed of light is approximately 300,000 kilometers per second. When you square that number, you get 9 times 10 to the power of 16 meters squared per second squared. It is an enormous number, astronomically large, which means that a very small amount of mass corresponds to a gigantic amount of energy. 1 kilogram of mass, any mass, a stone, a book, 1 kilogram of your own body, contains approximately 9 times 10 to the power of 16 joules of energy. To put that in perspective, that is approximately the energy released by 20 megatons of TNT, more than the largest nuclear bomb ever detonated. All that hidden in a single kilogram of ordinary matter. But here is the crucial part. We cannot access all that energy easily. In normal chemical reactions, like burning gasoline, we only convert a tiny fraction of the mass into energy. In nuclear reactions, like fission in nuclear power plants or fusion in the sun, we convert approximately 0.1% of the mass into energy. That is enough to power cities or make stars shine, but it is still a minuscule fraction of the total. The only way to convert all the mass into energy is through matter-antimatter annihilation. When a particle meets its antiparticle, both disappear completely, turning into pure energy, 100% efficiency, and the amount of energy released is exactly energy equals mass multiplied by the speed of light squared. Einstein derived this equation in 1905. The same year, he published his theory of special relativity, but he did not derive it thinking about nuclear bombs or fusion reactors. He derived it thinking about photons and motion. He realized that when an object emits light, it loses a small amount of mass, and when he calculated exactly how much mass was lost, He found this simple and beautiful relationship. What Einstein understood is that mass is not just a property that things have. Mass is rest energy. It is energy that is, so to speak, locked into the structure of matter. When you are sitting still, not moving at all, you still have enormous energy simply by existing, simply by having mass. This is your rest energy, and this is where it connects with the speed of light. When you start to move, you gain additional kinetic energy. In Newtonian physics, this kinetic energy is simply 1/2 the mass multiplied by the velocity squared. But Einstein showed that this is only an approximation that works at low speeds. The full relativistic formula is much more complex, and what it shows is that the faster you move, the more energy you gain. Not just kinetic energy, energy that manifests as an increase in your effective mass. This is the deep connection. Energy and mass are interchangeable. When you add energy to an object, you increase its mass. When you extract energy, its mass decreases. And at the limit, when you try to accelerate something to the speed of light, the amount of energy you need to add becomes infinite, which means the object's mass would become infinite, which is another way of saying it is impossible. But there is something even deeper here. The equation energy equals mass multiplied by the speed of light squared does not just tell you how much energy mass contains. It also tells you why the speed of light is special. The speed of light squared is not a random number in this equation. It is fundamental to the structure of spacetime. Think of it this way. Space and time are not separate entities. They are aspects of a single four-dimensional thing called spacetime. And in this four-dimensional spacetime, there is a metric, a way to measure distances. In ordinary three-dimensional space, the distance between 2 points is the square root of the sum of the squares of the differences in their $x, $y, and $z coordinates. Basic Pythagoras. In four-dimensional spacetime, there is a similar formula, but with a crucial difference. The time dimension enters with a negative sign, and the factor that multiplies the temporal dimension is the speed of light squared. This factor, $c circumflex, $2, is what connects the units of time with the units of space. It is what makes it possible for space and time to be aspects of a single thing. And here is the revelation. The speed of light is not really about light. It is about the structure of spacetime itself. It is the speed at which causality propagates. It is the maximum speed at which any information, any influence, any cause can travel from one point to another in the universe. Photons travel at this speed not because they are special, but because they have no mass. Any massless particle must travel at exactly the speed of light. It cannot go slower. It cannot go faster. It is the only possible speed for something that has no mass. And the reason is, precisely, energy equals mass multiplied by the speed of light squared. If a particle has no mass, its rest energy is 0. But particles can have energy even without mass, in the form of pure kinetic energy. And it turns out that for a massless particle, the only way to have energy is to move at exactly the speed of light. Slower, and it would have no energy. Faster is mathematically impossible. This means that there are two types of things in the universe. There are things with mass that always travel slower than light, that experience time, that have history. And there are things without mass that always travel exactly at the speed of light, that do not experience time, that exist in an eternal present. There is no middle ground. There is no gradual transition. The line between these two types of existence is absolute. And energy equals mass multiplied by the speed of light squared is the equation that defines this line. It is the equation that says, if you have mass, no matter how small, You are on the side of things that experience time, and you can never, ever, under any circumstances, cross to the other side. This equation also explains why the speed of light is the limit of causality. Causality means that causes precede effects, that you can remember the past but not the future, that actions have consequences that unfold forward in time. But if something could travel faster than light, causality would break. Imagine you send a signal faster than light to someone who is moving away from you at high speed. Due to relativistic effects, from that person's frame of reference, your signal could arrive before you sent it. You could receive a response to your message before sending it. The effect would precede the cause. The future would influence the past. The timeline would become entangled in an impossible knot. Energy equals mass multiplied by the speed of light squared prevents this. By making it impossible for anything with mass to reach the speed of light, it ensures that causality remains intact. It ensures that the universe makes sense, that there is a coherent flow from the past to the future, that actions have predictable consequences. This equation, these 5 simple symbols, encapsulate all this: the interchangeability of mass and energy, the reason why the speed of light is an absolute limit, the structure of spacetime, the preservation of causality, the fundamental division between things that experience time and things that do not. And the most beautiful thing of all, this equation is symmetrical. It works in both directions. Not only can mass be converted into energy, energy can be converted into mass. In fact, this happens all the time in particle accelerators. Physicists take high-energy photons, pure massless energy, and collide them. And from that collision emerge particles with mass: electrons, positrons, protons, particles that did not exist before, created purely from energy. The early universe worked like this. In the first moments after the Big Bang, when the universe was incredibly hot and dense, energy was constantly converting into mass, and mass into energy. Particles appeared out of nowhere and disappeared back into pure energy. It was a chaos of constant transformation, governed entirely by energy equals mass multiplied by the speed of light squared. As the universe cooled, this frantic dance slowed down. Energy froze into mass. Particles stabilized. Atoms formed. And eventually, all the matter that makes up the stars, the planets, and your own body emerged from this process. You are literally frozen energy, ancient light converted into matter, and energy equals mass multiplied by the speed of light squared is the recipe that created you. This is the equation of destiny. Not just because it gave us nuclear weapons or nuclear power, although it did both. It is the equation of destiny because it defines what is possible and what is not. It defines that if you have mass, if you exist as matter, then you are subject to certain rules. You cannot reach the speed of light. You cannot escape the flow of time. You cannot travel faster than causality. These are not limitations imposed by technology or engineering. They are limitations imposed by the very structure of reality. And energy equals mass multiplied by the speed of light squared is the signature of that structure. It is the universe saying, these are the rules of the game. Play within them. There is a fundamental misunderstanding about the speed of light that persists even among educated people. You hear it all the time, the speed of light, as if this limit were a special property of photons, as if light had some unique privilege in the universe. But here is the truth that changes everything. This limit has nothing to do with light itself. Light was simply the messenger that revealed this secret to us. The limit is much deeper. It is the limit of causality itself. It is the maximum speed at which anything can influence anything else in the universe. Think about it. When you push a door, Your hand does not directly touch the atoms of the door. What really happens is that the electrons in the atoms of your hand electromagnetically repel the electrons in the atoms of the door. This electromagnetic force propagates between them. And at what speed does this force travel? Exactly at the speed of light, neither faster nor slower. When the sun disappears, when it finally exhausts its nuclear fuel in about 5 billion years, we will not know instantly. Earth will continue to orbit for exactly 8 minutes and 20 seconds more, the time it takes for light and gravity to travel from the sun to the Earth. Because gravity, that mysterious force that keeps planets in orbit, also propagates at exactly the speed of light. This was one of the deepest predictions of Einstein's theory of general relativity. In Newtonian physics, gravity acted instantaneously. If the sun disappeared, Earth would fly out of its orbit immediately, without delay, without travel time. But Einstein showed that this was impossible. Gravity cannot travel instantaneously because nothing can travel instantaneously. Gravity is a ripple in spacetime, and those ripples propagate through the cosmos at exactly the speed of light. And this is not just theory. In the year 2015, scientists directly detected gravitational waves for the first time, using the Laser Interferometer Gravitational Wave Observatory, known as LIGO. Two black holes, more than 1 billion light-years away, had violently merged. The collision sent massive waves through spacetime, stretching and compressing the fabric of the universe itself. And those waves traveled for more than 1 billion years before reaching Earth, moving at exactly the speed of light. We can measure their speed. We know exactly how fast they traveled, and it is the same speed as light, not because gravity is light, but because both are limited by the same fundamental law of the universe. But it does not stop there. All the fundamental forces of nature are subject to this same limit. Electromagnetism, the weak force that governs radioactive decay, the strong force that holds atomic nuclei together, all travel at the speed of light. They cannot go faster. The universe simply does not allow it. This means something extraordinary. It means that information cannot travel faster than light. And when I say information, I do not just mean messages or data. I mean any causal influence, any way in which an event in one place can affect what happens in another place. That influence is limited to traveling at the speed of light at most. This is a profound restriction. It means that the universe has an integrated causal structure. If you are 10 light-years away from me, nothing you do now can affect me for at least 10 years. There is no way to avoid this. There is no technological trick. There is no loophole in the laws of physics that allows you to influence me faster. We are causally disconnected for those 10 years. We exist in separate regions of space-time, unable to influence each other until light has time to travel between us. Physicists call this the light cone. Imagine a cone extending from you into the future. Everything inside that cone are events that you could potentially influence. Everything outside that cone is beyond your causal reach, at least for now. As time passes, the cone expands, but the speed at which it expands is determined by the speed of light. You cannot reach outside your light cone, not even with advanced technology, not even in principle. And there is a similar cone extending into the past. All the events that could have influenced you, all the possible causes of your present state, must be within your past light cone, and something is outside that cone. It is so far away that light has not had time to travel from there to you, which means it could not have affected you in any way. This structure of light cones defines the causal structure of the entire universe. It defines what can affect what. It defines what events are connected and what events are isolated. And everything depends on a finite speed limit existing. If things could influence each other instantaneously, If signals could travel infinitely fast, this entire structure would collapse. There would be no light cones. Everything would be causally connected to everything else, regardless of distance. The universe would be a fundamentally different place. Here is another way to think about it. The concept of now is relative. When you say, at this moment something is happening on Mars, that only has meaning because you are defining now according to your own frame of reference. But someone moving at high speed relative to you would have a different now. Events that you consider simultaneous, they would consider to occur at different times. But there is one thing that everyone agrees on, no matter how they move. If two events are causally connected, if one could have influenced the other, then there is a defined temporal sequence between them. All observers will agree on which came first and which came after. The causal order is preserved, and the reason it is preserved is because nothing can travel faster than light. If signals could travel faster than light, different observers would not agree on the order of causally connected events. Some would see the cause before the effect. Others would see the effect before the cause. Causality itself would break. The universe would become incoherent, paradoxical, impossible. So when we say the speed of light, what we really mean is the speed of causality. It is the maximum speed at which causes can propagate. It is the fundamental limit of how fast anything can happen in the universe. Photons travel at this speed because they have no mass. Gravitons, the hypothetical particles that carry the gravitational force, would also travel at this speed because they also have no mass. In fact, any massless particle must travel at exactly this speed. It is not a choice. It is a mathematical necessity. But the speed itself is not about these particles. It is about the structure of spacetime. It is a geometric constant of the universe. Like pi is a geometric constant of circles. We do not choose it. We cannot change it. It is simply part of how the universe is constructed. And here is something that will make you think from the perspective of a photon. If it could have a perspective, there is no time and no distance. A photon emitted by a star 1 billion light-years away and absorbed by your eye experiences 0 time. From its point of view, it was emitted and absorbed in the same instant. The 1 billion years that elapsed from our perspective simply do not exist for the photon. This means that all photons in the universe, all of them, exist in an eternal present. They have no past, they have no future, they only exist in a single, timeless moment. And this is true not only for photons, but for anything that travels at the speed of light, including gravitational waves, gluons that hold quarks together, and any other massless influence. The universe is then divided into two realms. There is the realm of things with mass, which experience time, which have history, which move slower than light. And there is the realm of things with no mass, which do not experience time, which exist in an eternal now, which travel at exactly the speed of light. And between these two realms, there is an absolute, impassable boundary, defined by this speed limit. We, with our mass, with our bodies made of atoms, live in the first realm. We are trapped in the flow of time. We experience the past, present, and future as a sequence. We remember what was and anticipate what will be. And the reason we can do this, the reason time has meaning for us, is precisely because we are on the correct side of this limit. The speed of light is not about the light. It is about time. It is about causality. It is about the structure that makes it possible for a coherent universe to exist. It is the boundary that separates change from eternity, sequence from the perpetual present, temporal existence from timelessness. And now you understand why this limit is so fundamental. It is not an arbitrary restriction. It is the very foundation upon which reality is built. Here is the question everyone asks, eventually. If nothing can travel faster than light, then what about the Big Bang? What about the expansion of the universe? Astronomers tell us that there are galaxies receding from us faster than the speed of light. Does that not break the rules? Does that not prove the limit can be violated? The short answer is no. The long answer is much more fascinating and reveals something profound about the difference between motion through space and expansion of space itself. Imagine you draw 2 points on the surface of a deflated balloon. Now inflate the balloon. The points move away from each other, but here is the crucial part. The points themselves are not moving through the surface of the balloon. The surface is expanding, carrying the points with it. There is no local motion. There is only expansion of the space between them. This is exactly what happens with the universe. Space itself is expanding. The galaxies are not flying through space, moving away from each other. They are being carried by the expansion of space itself, and it turns out that there is no speed limit for how fast space can expand. The speed of light limit only applies to motion through space, not the expansion of space itself. Think of it this way. If you have 2 galaxies separated by 1 billion light-years, and the space between them expands in such a way that after 1 year they are separated by 2 billion light-years, then from our perspective they appear to have moved 1 billion light-years away in 1 year. That is faster than the speed of light. But neither of the galaxies actually moved. No object traveled through space faster than light. The space itself simply expanded. And in fact, there are regions of the universe receding from us so fast due to the expansion that the light from those regions will never reach us. They are beyond what we call the cosmological event horizon. Not because they are moving through space faster than light, but because the cumulative expansion of the space between us and them is so great that the light, despite traveling at its constant speed, can never close the gap. This means that there are parts of the universe that are causally disconnected from us forever, not just now, but for all eternity. The light they emit will never reach us. No signal, no information, no influence from those regions can ever affect us. They exist in a completely separate realm of reality, cut off from us, not by distance, but by the expansion of space itself. But this does not violate relativity. Special relativity says that nothing can move through space faster than light. It says nothing about how fast space itself can expand. That is a question for general relativity, Einstein's theory of gravity, and the structure of spacetime. And general relativity allows space to expand at any speed. Now let us talk about another apparent exception, quantum entanglement. This is something that confuses almost everyone, even experienced physicists when they first encounter it. Quantum entanglement is a phenomenon where 2 particles can be connected in such a way that measuring one instantly affects the other, no matter how far apart they are. You could have one electron on Earth and another on Mars, and when you measure the spin of one, the spin of the other is instantly determined, with no delay, no travel time, instantaneous. Einstein hated this, calling it spooky action at a distance, and he thought it proved that quantum mechanics must be incomplete, because if information could travel instantly between entangled particles, then relativity would be wrong. The speed of light limit would be violated. But here is the crucial part, the part that saves everything. Although the correlation between the entangled particles is instantaneous, you cannot use this to send information. You cannot use quantum entanglement to communicate faster than light. The reason is subtle, but absolute. When you measure one entangled particle, you get a random result. You cannot control what result you get. And although that result is perfectly correlated with what will be measured on the other particle, the person measuring the other particle also sees a random result. Only when they compare their results, using normal communication channels limited to the speed of light, do they discover the correlation. It is as if the universe plays an extremely sophisticated game to keep causality intact. It allows these bizarre, non-local correlations, but structures the rules in such a way that you can never use them to send an actual signal. Information, causality, is still limited to the speed of light. Quantum entanglement does not violate it. It only looks like it does until you understand the details. There is another apparent exception people bring up: tachyons. Tachyons are hypothetical particles that would always travel faster than light. They appear in some equations of theoretical physics, and for years physicists wondered if they could truly exist. The answer turns out to be no. If tachyons existed, they would violate causality in a fundamental way, creating temporal paradoxes, allowing effects to precede causes. The universe would become mathematically inconsistent. So now we understand that the equations that seem to allow tachyons were actually pointing to instabilities in the theory. Tachyons are not real particles. They are mathematical warning signs that say, this theory needs fixing. And what about wormholes? Those hypothetical shortcuts through spacetime that appear in science fiction movies. If you could create a wormhole connecting the Earth to a star 1,000 light-years away and walk through it, would you not have effectively traveled faster than light? Technically, no. You did not move through space faster than light. You took a shortcut through a different geometry of spacetime. It is like the difference between traveling around a mountain versus digging a tunnel through it. You are not violating any speed limit. You are simply using a different route. But here is the problem. We do not know if wormholes can actually exist. The equations of general relativity allow them in principle, but only if something called exotic matter with negative energy density exists. And we are not sure if such a thing can exist in reality. Every time physicists try to construct a realistic model of a traversable wormhole, they run into problems. The required exotic matter would have properties so strange that it might violate other laws of physics. And furthermore, even if you could create a wormhole, it might be fundamentally unstable, collapsing as soon as you tried to use it. So wormholes remain in the realm of theoretical speculation. Perhaps they exist, perhaps they do not, but even if they do, they would not violate the speed of light limit. They would just provide a clever way to circumvent it using the geometry of spacetime. There is one last phenomenon that seems to violate the speed limit: phase velocities. Imagine you create an interference pattern by moving two sets of waves past each other. The pattern, the places where the waves reinforce and cancel, can move faster than the individual waves. In fact, under the right conditions, the pattern can move faster than light. But here is the key. The pattern itself is not a physical thing. It does not carry energy or information. It is just a pattern, like shadows moving across a wall when you move a flashlight. The shadow can move faster than light, but that does not matter because the shadow is not a real thing. It does not transport causality. It cannot be used to send a signal. Similarly, there are circumstances in optics where the bright spot of a laser pointed at a distant screen can move faster than light if you swivel the laser fast enough. But again, the spot is not a physical thing. It is just the location where the current light beam hits the screen. There is no real object traveling along the screen. There are only individual photons, each traveling from the laser to the screen at exactly the speed of light. All of these apparent exceptions turn out to be no exceptions at all once you understand them correctly. The speed of light limit refers specifically to the movement of matter, energy, and information through space. It refers to causality. It refers to the ability to influence events, send signals, transport something from one place to another, and that limit is never violated, not even once, not even a little. Every experiment, Every observation, every theoretical prediction confirms it. The universe is extraordinarily consistent in enforcing this rule. Why? Because the alternative would be chaos. If the limit could be violated, if signals could travel faster than light, then the causal structure of the universe would fall apart. Time would lose its meaning. Causes and effects would become entangled. The universe itself would become paradoxical and impossible. So when you hear about something apparently going faster than light, ask yourself, is it really a physical thing moving through space? Does it transport energy or information? Can it be used to causally influence events? If the answer is no, then it is not really an exception. It is just an interesting phenomenon that appears to violate the limit, but really does not. The limit remains absolute, inviolable, fundamental. There are no exceptions. There is only a deeper understanding of what the limit truly means. Let us do a thought experiment. Imagine for a moment that the universe has no speed limit. Imagine you can build a spaceship that travels at twice the speed of light, or 10 times faster, or 1,000 times faster, with no restrictions, no barriers, just pure, unlimited speed. It sounds liberating, does it not? It sounds like the universe should be, without chains, without prisons, total freedom to explore the cosmos at any speed you desire. But there is a problem so fundamental, so devastating, that it makes the whole concept fall apart. In a universe with no speed limit, causality itself stops working. Causes would no longer necessarily precede effect. You could receive answers before you ask questions. You could see explosions before the bombs went off. You could experience consequences before you make decisions. The flow of time, as we understand it, would disintegrate into incomprehensible chaos. Let me show you exactly how this would happen. Imagine you are on Earth, and your friend is on a spaceship, moving away from you at half the speed of light. You send a signal to your friend, traveling at twice the speed of light. From your perspective, the signal leaves after you send it. That makes sense. Cause, then effect. But now let us shift to the perspective of your friend in the spaceship. Due to relativistic effects, because of the way time and space are related when things move at high velocities, your friend would perceive events differently. And here is the terrifying part. If the calculations are done correctly, your friend would see the signal arriving before you sent it. The effect would precede the cause. The future would influence the past. Now imagine your friend immediately replies by sending a signal back to you, also traveling at twice the speed of light. From your friend's perspective, this happens after receiving your signal. But when that reply signal gets back to you, due to the way the relativistic effects stack up, you might receive it before you sent your original signal. You would receive an answer to a message you have not yet sent. This is not just weird. It is a fundamental paradox. It is a violation of logic itself. Because now, you could use this information from your future answer to decide not to send the original signal. But if you do not send the original signal, how did you receive the answer? The chain of causality forms an impossible loop, a temporal knot that cannot be untangled. Physicists call this a closed time-like curve, and if they were possible, they would allow all sorts of paradoxes. The most famous is the grandfather paradox. You travel to the past and kill your own grandfather before your father was conceived. But if your father was never born, then you were never born. So how did you travel to the past to kill your grandfather? It is a logical contradiction, and impossible. Now, some people try to escape these paradoxes with clever ideas. Maybe the universe has multiple timelines. Maybe when you travel to the past, you create an alternative reality. Maybe there is some self-consistent mechanism where the paradoxes resolve themselves. But these are all tricks. They are ways of trying to salvage the idea of faster-than-light travel by adding additional complexities to the universe. The simplest, most elegant solution is that the universe simply does not allow faster than light travel in the first place. No paradoxes, no multiple timelines, no complicated self-consistent mechanisms. Just a simple rule. Nothing travels faster than light, and therefore causality remains intact. But let us delve deeper. What does causality truly mean? At its core, it means there is an arrow of time. There is a defined direction from the past toward the future. You can remember the past, but not the future. You can influence the future, but not the past. This asymmetry is fundamental to how we experience reality. And this asymmetry exists because information, causal influences, propagate forward in time at a finite speed. If you could send information backward in time, if you could influence events that have already happened, then this arrow would break. The past and the future would become entangled. There would be no clear direction of time. Think about what this would mean for basic concepts like memory. Memory works because there is a unidirectional flow of information from the past to the present. You experience something, and that experience leaves a trace in your brain that persists into the future. But if information could flow backward in time, you might remember things that have not happened yet. The distinction between memory and precognition would fade away. Or think about decision-making. You make decisions based on your knowledge of the past and your expectations about the future. But if the future could influence the past, then your decisions could be influenced by their own consequences. You might be dissuaded from taking an action by the knowledge of what that action will result in, but that knowledge only exists because you took the action. It is circular. It is paradoxical. It is impossible to make sense of. Or consider the concept of free will, whatever that may mean. Most people feel they have the ability to make choices, to select among options. But if the future is already influencing the present, if your choices are already being affected by their consequences, what does it truly mean to choose? The very notion of choice depends on a temporal structure where you make a decision now that affects what happens later, not where what happens later affects your decision now. Now, all these fundamental ideas about how reality works depend on causality, and causality depends on there being a speed limit for how fast influences can propagate. Without that limit, everything falls apart. But there is something even deeper. In modern physics, we understand that time is not completely separate from space. They are aspects of a single four-dimensional entity called spacetime. And in spacetime, events do not just have a location in space and a moment in time. They have a position in four-dimensional spacetime. And in this four-dimensional spacetime, there is a geometric structure defined by the speed of light. This structure determines which events can causally influence each other. If two events are close enough in space and time that a light signal could travel from one to the other, then they are causally connected. One could potentially influence the other. But if they are too far apart, if not even light could travel between them in the time available, then they are causally disconnected. They cannot influence each other. This geometric structure, this division of space-time into causally connected and disconnected regions, is fundamental to how the universe works, and it depends completely on there being a finite speed limit. If signals could travel infinitely fast, then every event would be causally connected with every other event. There would be no structure, no boundaries. Everything would instantly influence everything else. It sounds like it might be interesting, but in reality, it would be catastrophic, because without causal structure, you cannot have coherent laws of physics. You cannot make predictions. You cannot have science. You cannot even have a comprehensible universe. It would be complete chaos. Every event affected by every other event simultaneously, with no order, no pattern, no meaning. The speed of light limit does not just prevent paradoxes, it creates the very possibility for the universe to make sense. It creates the possibility for there to be laws, patterns, regularities. It creates the possibility for effects to follow causes in a predictable manner. It creates the possibility for us to understand anything at all. And there is another aspect. In a universe with no speed limit, the concept of here and now would lose all meaning. Because if influences could travel instantly, then now would stretch across all space simultaneously. There would be no delay, no travel time, no separation between events in different locations. Everything would be happening now, everywhere. But this deeply violates our experience of reality. We experience locality. Things that happen here affect us differently than things that happen there. There is a distinction between near and far, between local and distant. And this distinction exists because influences take time to propagate, because there is a speed limit. Without that limit, locality would disappear. Everything would be instantly connected to everything else. You would not be a localized being experiencing events in sequence. It is not even clear what you would be, because the very notion of being a localized individual in space and time depends on these speed limits. So, here is the terrifying conclusion of the thought experiment. A universe with no speed limit would not just be different from ours, it would be fundamentally incoherent. It would be a universe where causality does not work, where time has no direction, where locality does not exist, where the laws of physics cannot be coherent, where nothing makes sense. The speed of light limit is not an annoying restriction imposed by a cruel universe. It is the very foundation that makes a coherent universe possible. Without it, there would be no science, no understanding, no thought, no you. The limit is not a prison. It is the bedrock upon which reality itself is built. There is an uncomfortable truth that we must face, a cold, hard fact about our place in the cosmos. We are trapped, not just on this planet or in this solar system, though that is true for now. We are trapped in a much larger, but equally impassable, bubble. A bubble defined not by physical walls, but by the most fundamental limit that exists, the speed of light. And this prison has profound consequences for the destiny of humanity and for our understanding of the universe itself. Let us start with what we can see. When you look up at the night sky, you are seeing light that has traveled through space to reach your eyes. That light did not arrive instantly. It took time. The light from the moon took approximately 1 second to arrive. The light from the sun took 8 minutes. The light from the nearest star after the sun, Proxima Centauri, took 4 years. The light from the Andromeda Galaxy, the closest large spiral galaxy to our own, took 2.5 million years. And when you look deeper into space using powerful telescopes, you see galaxies whose light has traveled for billions of years. The most distant galaxies we have detected emitted their light over 13.8 billion years ago when the universe was young. We are literally viewing the ancient past of the cosmos. But here is the crucial part. There is a limit to how far we can see, not because our telescopes are not powerful enough, but because the universe itself has a finite age. The Big Bang happened approximately 13.8 billion years ago. Light has only had that time to travel, which means there is a sphere around us with a radius of 13.8 billion light-years called the observable universe. Everything inside that sphere is potentially visible to us. Everything beyond is beyond our horizon. Its light has not yet had time to reach us. But it gets worse. The universe is not just old, it is expanding, and that expansion is accelerating. Distant galaxies are moving away from us faster and faster as the space between us expands, and there is a distance beyond which galaxies are receding so fast that the light they emit will never reach us. They are beyond what is called the cosmological event horizon. This horizon is at approximately 17 billion light-years away. Any galaxy beyond this horizon is lost to us forever. Not just now, forever. No matter how long we wait, no matter how advanced our telescopes become, we will never see those galaxies. They are causally disconnected from us. They exist in a part of the universe that can never interact with ours. And as time goes on, this horizon is getting closer. More and more galaxies cross this limit and disappear from our observable universe forever. In about 100 billion years, almost all galaxies, except those in our local group, will have crossed the horizon. A future astronomer, looking at the sky, would see only a handful of nearby galaxies. The rest of the universe would have disappeared, not because it ceased to exist, but because the expansion of space carried them beyond the reach of their light. This is the cosmological prison. We are confined not only to our current observable universe, but to an observable universe that is contracting with time. The cosmos is getting lonelier, and there is nothing we can do about it. But let us focus on a more human timescale. The closest galaxy to the Milky Way is Andromeda, at 2.5 million light-years away. If we sent a spaceship toward Andromeda, traveling at 99% of the speed of light, it would take approximately 2.5 million years to get there from our perspective on Earth. From the perspective of the astronauts on the ship, due to time dilation, it would take much less time, perhaps only 350,000 years of subjective time. Still, innumerable generations. And here is the problem. Even if we could build such a ship, even if we could get that close to the speed of light, the journey would still be one way. The astronauts could never report back to Earth about what they found. Any signal they sent would take 2.5 million years to return. The civilization that sent them would have long disappeared. The Earth itself might be unrecognizable, and Andromeda is our closest neighbor. Most galaxies are much farther away. Traveling to them, even at near light speeds, would take tens or hundreds of millions of years. It is incomprehensible. It is beyond what any civilization could reasonably endure. So we are trapped, not just in our galaxy, but realistically in a small region of our galaxy. The distances are simply too vast. The speed limit is too restrictive. Even if we expand to the stars, even if we colonize thousands of solar systems, we will still be confined to a small corner of the Milky Way. The farthest stars might as well be in another universe. They are beyond our reach, for all practical purposes. And there is something profoundly melancholy about this. We look up at the night sky and see billions of stars, hundreds of billions of galaxies, a vast cosmos beyond comprehension. And almost all of it is out of our reach, not because of technological limitations that we might one day overcome, but because of the fundamental laws of physics. The universe shows us its immensity, but denies us access to most of it. But here is the paradox. This prison, this restriction, is also what makes the universe beautiful, because the fact that light has a finite speed means we can see the past. When we look at distant galaxies, we are seeing what they were like billions of years ago. We are witnessing the history of the universe unfolding before us. The night sky is a time machine, showing us the evolution of the cosmos from its earliest days until now. Without the speed of light limit, without the finite travel time of light, we could not do this. We would see everything as it is now, whatever that means. We would have no window into the past. We could not track the history of galaxies, the formation of stars, the evolution of cosmic structure. All that information would be lost. So the limit that imprisons us is also what enables us to understand. It is a restriction and a gift at the same time. It denies us physical access to most of the universe, but it gives us intellectual access to its complete history. We can see the infancy of the cosmos recorded in the light of distant galaxies. We can trace how the universe evolved over time. We can reconstruct the complete cosmic story from the Big Bang to the present. And there is another way this prism is beautiful. The fact that cosmic distances are so vast, the fact that we are so isolated, means we are forced to value what we have close by. This planet, this solar system, these neighboring stars. We cannot just move to another galaxy if we ruin this one. We are here. This is our home. And these limitations force us to appreciate it. There is a certain humility in recognizing how small we are, how confined we are. The universe is vast beyond imagination. And we are a tiny species on a small planet, orbiting an average star in an ordinary galaxy. And almost all the rest of the universe is beyond our reach, forever. But there is also something empowering in this, because within our small corner of the cosmos, within the limits imposed by the speed of light, there is still an amazing immensity. There are still billions of stars in our galaxy. There are still innumerable worlds to explore, innumerable phenomena to understand, innumerable mysteries to solve. The prism is large. We could explore for millions of years and never exhaust the wonders within it. The restrictions do not deny us adventure. They just define the stage on which that adventure unfolds. And perhaps most importantly, these restrictions connect us to the fundamental nature of reality. They force us to confront how the universe really works. Not how we would like it to work, not how science fiction imagines it, but how it actually is. And there is a deep beauty in that confrontation with truth. The speed of light limit is a prison, but it is the most beautiful prison imaginable. It is one that teaches us humility, patience, and appreciation. It is one that gives us access to the universe's past, even as it restricts our access to its present geography. It is one that keeps us connected to our home. Even as we dream of the stars, we are confined, but within that confinement, there are still infinite possibilities. There is still wonder, there is still mystery, and there is still beauty. The prism is not the end of the story. It is the framework within which our story is told. We have reached the end of our journey. We have explored the number that defines reality. We have seen why energy becomes infinite. We have experienced how time stops and space contracts. We have understood that $E equals mc circumflex 2 seals our destiny. We have discovered that this limit is not about light, but about causality itself. We have examined the apparent exceptions and seen that they are no exceptions at all. We have imagined the collapse of reality without this limit and have contemplated the beautiful prison we find ourselves in. But now we must ask ourselves the deepest question of all. Why? Why does this limit exist? Why is the universe constructed this way and not another? And the answer, when you truly think about it, is astonishing. This limit is not an arbitrary restriction. It is not a design flaw. It is not a cruel limitation imposed by an indifferent cosmos. It is the very condition that makes it possible for you to exist, to ask about it. Think about it. Everything you are depends on the flow of time. Your consciousness is a temporal process. Your thoughts unfold in sequence. You experience one moment, then the next, then the next. Memory works because the past persists in your brain toward the future. Anticipation works because you can project consequences forward. Your very sense of identity depends on temporal continuity, on the feeling that there is a you that persists from one moment to the next. But all of this, absolutely everything, depends on there being a coherent, causal structure. It depends on causes preceding effects. It depends on time flowing in one direction. And that structure can only exist if there is a speed limit for how fast causal influences can propagate. Without the speed of light limit, there would be no arrow of time, no causality, no memory, no thought, no you. So when you feel frustrated by this limit, when you wish you could travel faster than light, when you long to explore distant galaxies, remember, the very limit that restricts your movement is what allows you to exist in the first place. You cannot have it both ways. You cannot have a universe with coherent causality and no speed limit. They are mutually exclusive. The universe chose causality, and with that choice, it chose you. But there is something even deeper. The speed of light limit does not just allow causality. It also allows complexity. It allows structure. It allows interesting things to happen. Because if everything were causally connected with everything else instantly, if every particle in the universe could influence every other particle without delay, then there could be no isolated systems, there could be no independent objects, there could be no levels of organization. Chemistry works because atoms can form molecules that are relatively stable, relatively isolated from external influences. Biology works because cells can maintain boundaries. They can regulate what comes in and what goes out. They can exist as discrete entities. Consciousness works, at least in part, because your brain is a relatively closed system that can process information without being instantly overwhelmed by every influence in the universe. This entire hierarchy of organization, from particles to atoms, to molecules, to cells, to organisms, to ecosystems, depends on there being limits. Limits in space, yes, but also limits on how fast influences can propagate. The speed of light limit creates the possibility of locality. It creates the possibility for things here to be different from things there. And that possibility is fundamental to all the complexity we see in the universe. Without that limit, the universe would be a homogeneous soup, every part instantly affected by every other part, with no structure, no organization, no complexity, and certainly no life, no consciousness, no beauty. The limit does not just allow your existence, it allows everything that makes existence worthwhile. And there is another dimension to this. The speed of light limit creates the concept of a horizon. It creates the idea that there are things beyond our reach, beyond our knowledge, beyond our influence. And horizons create mystery. They create curiosity. They create the desire to explore, to understand, to reach beyond our current limits. If there were no horizons, if we could see and access everything instantly, what would be left to discover? What would motivate exploration? What would drive science? The fact that there are limits, that there are things we do not know, that there are regions of the universe we can never reach. That is what pushes us forward. It is what makes the pursuit of knowledge meaningful. Restriction creates meaning. Limits create purpose. The impossibility of knowing everything, of going everywhere, of doing everything, is what makes our real achievements valuable. If everything were possible, nothing would be special. If there were no limits, there would be no achievement. So the speed of light limit is not the enemy of human meaning. It is its source. It is not a barrier to our potential. It is what makes potential exist at all. It does not deny us purpose. It gives it to us. And here is the final paradox, the most beautiful of all. This limit, this you cannot, is actually a you can. You cannot travel faster than light, but you can exist. You cannot escape causality, but you can think. You cannot reach every corner of the universe, but you can understand the fundamental principles that govern every corner. You cannot break the laws of physics, but you can discover what those laws are. The universe has given you an extraordinary gift. It has given you a cosmos that makes sense, a cosmos with patterns, a cosmos with laws, a cosmos that can be comprehended. And the price of that gift is that there are limits. Limits on how fast you can go, limits on what you can know, limits on what you can do. But consider the alternative. A universe without limits would be a universe without structure, without meaning, without comprehensibility. It would be chaos. It would be noise. It would be nothing that could sustain life, consciousness, or meaning. The limits are not flaws of the universe. They are its features. They are what makes it a cosmos, instead of chaos. And among all limits, the speed of light limit is the most fundamental. It is the one that connects space with time. It is the one that preserves causality. It is the one that allows complexity. It is the one that creates horizons. It is the one that makes existence itself possible. So the next time you look at the stars and feel the frustration of how far away they are, how unreachable they are, remember this: the very law that puts them out of your reach is the law that allows you to be here looking at them. The very restriction that limits your speed is the one that enables your thought. The very limit that creates the prison is the one that makes the prison worth inhabiting. 300,000 kilometers per second, 299,792 kilometers, and 458 meters per second, to be exact. It is not just a number, it is the signature of the universe. It is the constant that makes reality real. It is the limit that allows existence. And in this limit, there is a profound lesson. The lesson that restrictions are not the enemy of freedom, they are its precondition. That limits do not destroy meaning, they create it. That the impossible does not diminish the possible, it defines it. And that the universe, with all its restrictions, with all its limits, with all its unbreakable laws, is not a prison. It is a home where time flows, where causes precede effects, where complexity can flourish, where life can emerge, where consciousness can awaken, where questions can be asked, where answers can be found, where beauty exists, where meaning is possible. And all because there is a limit, an absolute limit, a fundamental limit, a limit you cannot break, but for which you should be eternally grateful, because without it, none of this would exist. Without it, you would not exist. This is the limit that allows existence, the speed of light, the most important constant in the universe, the law you cannot break, and the reason you are here to try.